for the choir kids. So if you guys talk to them and they still need to look at this, they can go home and figure it out. Okay? So what we have here is the work from yesterday, kind of, right? This was your figure yesterday, and you did that rubber band projection where you used rubber bands to copy a figure, this figure 1 to figure 2. And I walked around and everybody's was bigger. So that's good. That should have happened. And then we talked about how your picture's not perfect because you were freehanding, kind of. So it doesn't look like mine because I just cloned it. So when you go home and do the questions in the book, you're not going to have perfection. It's like a science experiment, not exact. Science experiments really are never exact. That's why you do tons of trials. So, but you should have been able to come up with some answers. And maybe you had a lot of answers that were on the right track, and maybe you had some answers that weren't on the right track, and that's what we're going to talk about. So I'm going to put this into 2-page view, and we're going to talk about some of those answers on page 11 in your new book, which is problem 1.1. And what I would really like is for you guys just to kind of tell me about what you came up with. So it says, using the rubber band method, enlarge the figure on the Mystery Club flyer. So this is the enlarged figure right here. You did that. Draw the figure as carefully as you can so you can compare size and shape. Okay? And then A says, describe how the original figure and the image are alike. So this would be the original. And this is the image. Okay? And the first thing they talk about on A is how are the general shapes alike. And then the next part is, how about the lengths of the shapes? So think about these. And then the third one is the areas and the perimeters. We'll start with those. And so if you looked at Allie's paper, it's just got a lot of writing. That's what it should look like. It shouldn't be, you don't necessarily need numbers. You might have some numbers. Okay? So, Allie, what did you notice about the general shapes?
They both have an obvious square. They both have one.
Okay, so they both have the triangle and really a rectangle, right? Okay. So what else? Someone else. Sammy?
I just said they generally look very similar, but just like different sizes.
Yeah. Okay, so they look similar, but they're different sizes, which would include what Allie said then what Allie said is in there, right? So it's a little bit more concise. So the word similar is actually a mathematical word. So now you might use the word similar a lot in your life, but today it's going to mean something very specific. So anytime I say similar, I'm going to mean something really specific. So we wouldn't use similar anymore unless we meant a very specific thing. But I'm going to give you something to think about here. So if I take this shape down here, this one right here, and I clone it, which would be kind of like how you, what is the thing It's not though. I think sometimes when I go to a single page, it just is fussy. Okay, when I clone it, you did the rubber band thing and it would enlarge it, right? Okay, but it did not distort it. Do you see what distorted is? That's distorted. and this is enlarged. Would you say that this picture up here that you guys did was enlarged and distorted, or just enlarged?
No, that doesn't look distorted.
Well, really, was yours totally distorted?
You can tell that they're the same, but yeah, you can tell. Little, like,
Because you're, okay, so yours looks more like this, right? And maybe it wasn't perfect.
Yeah.
You know.
Way better than mine.
Okay, but, so what I'm asking, what, did anybody that had, like, I mean, this would be like totally distorted. Right? Yours shouldn't look totally distorted. If it does, you did something wrong. Ben.
So an image that's not distorted would be an image where all of the angles
Perfect.
are the same.
Yes, all the angles should be the same. That's really, so what we would say is the corresponding angles. So, not all the angles, that's not really what you mean, but we'll talk about that. Watch this. You love the smart board? Corresponding angles are the same. So that's another word we have to understand. What it means to be corresponding. But the sides, what do you think about the sides, Ben?
The sides don't have to be, well, the sides are not all going to be the same as the original image.
No, they're not the same. The sides are different, right? They're different lengths. So the sides have different lengths. Did anybody notice anything else? What about the sides, Suki? Did you?
Well, I don't really know if this has to do with much, but I found that if you times the original by 2, you get the image.
Yeah, I think that you should be really close to what Suki's saying. Okay? So, if you measured, I'm going to show you kind of what she's saying with a little bit of a picture here. So, if you took a length like this and brought it over here, when you, on your image, it should be close to double. It might be a little less than double. Mine's a little more than double. Because there was an error. Did that happen? Only happened on Hannah's and Suki's? Did you guys do this?
I just said I noticed twice.
Almost twice as big? Did we notice that?
I just said it was like 2 to 3 centimeters shorter.
Okay, so hang on to that thought. Nick.
I found that the hat was placed a little higher up on the shape one.
And I think that would probably just be because your rubber banding wasn't perfect. You know. But in general, so Samantha, you kind of missed, I think, what you were looking for on this one, so that's why we're talking about it. It's more, I bet if you look back at it, with the same numbers that you have, you're going to see that it's about double. It's not going to be perfect, right? Because it was like a science experiment. It was an experiment. But the ratio of the big one to the small one, did you see how I did that? I picked a different side and it worked out about the same. And if I pick a third one, it should also work. And if I do this with the hat, it should work. That one small one makes close to half of one big one, right? So the big one's about twice as big. Would you say the sides are about the same ratio then? Yeah. We're going to do that. That's a great question. So the sides are different lengths, but the corresponding sides are what we call proportional. Yeah. About, in this case, it was about 2 to 1. Okay? That's right. So look at all the words here, because if you don't understand the words, none of this makes sense. None of this. Like corresponding is a new word usually for people in math. No, what corresponding means is
In relation to?
the relative positions have to be the same. So like, this angle here, angle 1, corresponds to this angle 1. Okay? This angle here, angle 2, corresponds to this angle 2. They're in the same relative position. So when somebody said somebody said the angles are the same, I said, I know what you mean, but really we wouldn't say this angle 1 is equal to this angle 2, would we? We mean that this angle 1 is equal to this angle 1 in the corresponding position, the one that's like in the same part of the picture. Does that make sense?
Yeah.
Isaiah?
Well, I said this for the lengths, but I guess probably with that one too. It's just kind of stretched. The sides are stretched.
They are stretched, which would make them proportional, but the way that they're stretched is the same. So, in other words, Isaiah, if you look down here, this is a stretch of this, but they're stretched differently. Like this one, when I look at just this one here, let's say I'll make it like that, right? Like the corresponding angle, the corresponding side to this is over here, right? And it takes about 3 of these here. So this would be about, let's say, 3 units where this is 1. But this one right here in purple, if I make this on this one and bring it over here and rotate it, if you could see, it's not going to take 3, is it? It takes just about 2. So this is a little more than 2 to 1 here, and this one is 3 to 1. So the sides are not proportional.
So how would you know, like, which one to start with for, like, the ratio? Would you do?
So, okay,
How would you do 3 to 1?
you wouldn't, right? So that's exactly what I'm trying to point out. In these 2 figures here, they're not what we would call similar. So if they're not similar, that's the new concept, then they're not going to have proportional sides and equal angles. But if they are similar, they are going to have proportional corresponding sides and equal angles, corresponding angles. So in other words, look at these 2. Without a lot of fancy math, the angles all match, right? The corresponding angles, can you see that? And look at these 2. I mean, the angles clearly don't match, right? So right away, you would just say they're not similar. Does that make sense? That's one criteria of similar figures. The second criteria, what's the second one, Mary?
Second one?
So the angles are equal. What other thing has to happen when the figures are similar?
They have to be the same shape.
And that would mean the angles are the same and the sides are, yeah, but not just different. Not necessarily 2 times, they just have to be in the same proportion. So I don't know what this one is. Let's check it. Like, I've got this here, I'm gonna clone it. Okay? I could do it with a ruler, but we're just kind of. So what if this were bigger? And I don't distort it. Okay? So if I clone this, now it's like, make it even a little bit bigger. Does it look like it's about 3 to 1 now? So if it's 3 to 1 on one side, it should be 3 to 1 everywhere. So if I do this one right here, if I clone this one, it should take about 3 of these. So it has to be the same ratio everywhere. So do you get that? If a figure's similar, 2 things have to happen. Angles are the same, sides are proportional. The corresponding angles are the same, the corresponding sides are proportional. Okay, questions?
So, what if it's not like, if you're like putting the lines on the shape and you have like 2.5?
Okay, eventually we're going to be doing it with measurements, so we won't be doing it like experiment, it'll be nice and neat.
So if it's 3.5, would it be 3.5 to 1?
Yes, in fact, that's possible. But let's finish this here just so I don't get sidetracked. So what do we know about the lengths of the shapes? They were equal? No. What were they?
Oh, wait a minute. For that one,
For the, yeah,
it was.
for the one you have for homework.
Oh, I thought. Never mind.
Okay, Nick?
They're proportional.
They were proportional, right? In about the ratio about 2 to 1. They would have been more close to exactly 2 to 1 if we had used the rubber bands that were exactly the same size, but they were a little bit off. Okay? You get that?
Mr. Chu just wanted to remind you I'm here.
I was going to check, thanks. Okay? So, Allie, we're going to answer your question, but I want to finish this first. What about the perimeters? Did anybody do perimeter? Yeah. What did you come up with? I'm just curious.
Well, I just added up all the sides for like the body, which was the biggest triangle.
Right?
For the original.
For the original, she got,
13.5.
okay. And what did you get for the new perimeter?
20.5.
Ooh, I think you might have made a mistake, actually. Were your sides about twice as big? Or were they about 1.5 as big? Like, tell me, because you might not have made a mistake.
Well, I did 7 plus 5 plus 8.5.
Mm-hmm. So you had like 7 here, 8.5 here, and 5. So that's good. So then did you have a close to, what did you have here? On the big one, bottom.
Or no. No, that was that. First one that I told you was for the bigger one.
Okay. You're not sure?
Yeah.
So Sammy,
So then for the other one,
yeah, tell me what you got for the other
I
one.
got 4.5.
Here?
Yeah.
Okay.
And then 5.5 on the other big side.
Uh-huh.
And then 3.5.
Okay. So your measuring is just a little bit different than some of the class, but that doesn't mean you're wrong. So this would be a good place to check what it means to do Allie's question. Let's see how well Sammy did, because if Sammy did a good job.
And I kind of like rounded up, so it was like 4 on purpose, or like, I just rounded it.
Well, there's maybe where the problem was. But if Sammy did a good job, these should be about the same. Do you see where I'm getting those? And this is kind of what your homework's gonna look like eventually, so you really wanna understand how to check to see if the sides are in the same proportion. You see how I made it a proportion? I went corresponding side big to small. No. You just make a ratio of this to this, and then you make a ratio of this to this. They should be about the same. If she measured really well, when I take the calculator out, 7 divided by 5.5 should be about the same. So this is 1.27, and 8.5 divided by 4.5. Yeah, so her measuring or her rubber banding probably wasn't as good as somebody else's. That's why when she said mine didn't really look proportional, I bet yours didn't look proportional. So that's when we look at everybody's. Okay, so that's why she would then look around the room and look at somebody else's. So AJ, did you measure?
I forgot to write down my, to measure stuff in my planner, so
So what'd you do? Tell me how you approach this problem.
I basically, because we're supposed to do problems A and C, right?
Yeah, A and C. So what'd you do?
So, like, for which part of
So the measuring part, the perimeters, comparing the perimeters.
I forgot to measure
So you didn't do it.
because I forgot to write that down.
Okay, so somebody else. Okay, so you need to go back and do that, because that's what's supposed to be done on the page. Does anybody else want to share their measures? Hannah? Okay. Okay, so it looks like this is what Hannah got 23. 20. Oh, okay. So hers is almost like hers is perfectly in the ratio 2 to 1. So she probably was just a little more careful. But we're gonna stick with Hannah's for a minute. Did you do area? Because everybody should watch the area. What did you do?
So the original area is
Uh-huh.
and for the drawn area, I got 30 centimeters.
How'd you get that?
I don't think that's
Yeah, it's not right. I want you guys to watch the area here. Should have been 60. So look at, Allie asked about area, like what if you forgot area? Look what I can do. You don't need to measure. Take this triangle and look at, I can slip it in here. Is that yellow hard to see back there?
How do you figure out the area? Because I know what I did wrong. Do you know the area?
Just give me a minute, okay? I'm just gonna make that a little darker. Or how about if I take that out? Can you see that? Watch. There's 4 that fit into it.
Oh, that's cool. So that you find the area of the original every time by 4.
Exactly. The ratio of the perimeters was, what was the ratio of the perimeters? 2 to 1, right? The perimeter was 2 to 1. But the area was 4 to 1. Do you know what you did wrong, Hannah?
I thought you divided by 2 because it's a triangle.
Mm-hmm.
But
You could divide by 2, but you didn't divide by 2 on both of them, probably. You forgot one place. That's what it looks like. Okay, and what was the ratio of the sides? Hannah, what was like your base of the small one?
I remember that.
It's probably safe to say her ratio was really close to 2 to 1 on the sides. Okay.
So like the area for the triangle
Right. Can you see why the area is 4 to 1?
And then 2 fit on the outside.
And exactly, like when you look at all the color stuff I did, 2 lengths fit to the 1 length here when you, right?
Yeah.
But the triangles inside, 4 triangles fit to every one. That would work for any shape, you guys. Not just triangles, but the triangle does it really nice. Okay, Evan, do you have a question? Grant?
So,
I apologize.
so like the overall image would be 2 to 1, not
Okay, so there's a question, right? How would you describe the overall image?
Yeah.
You can't do it just with numbers. You would have to say the perimeters of the images are in the ratio 2 to 1, but the areas of the image are in the ratio 4 to 1.
Okay.
Okay, before we get too much farther, I want you to stop for a minute and then I'll take questions, but I want you to write down something that we talked about was the similar, what it means for figures to be similar.
Wait.
They have to be the same shape, but they're going to be different sizes, right? I don't know why this is a 2 and a 3, it should be a 1 and a 2. So 2 figures are similar. What makes them similar is they're the same shape and different sizes, okay? And when they're different sizes, that means all the corresponding angles are equal, but all the corresponding sides are proportional. So there's all that vocab in here. The word similar is the key. That's what we're just describing here, similar figures.
That is our notes.
Yeah, that should be your notes. We're going to come back to that a lot this booklet. So take a minute to do that. So Sammy said, this is really important, you guys. I should be able to take one small hat and fit in to the big hat how many times?
4.
4. Let's see if it works. She doesn't even need, you guys don't even need me to do it now, right? Because you should probably, like, I think you get it. But if you need to, if you're one of those people you'd like to believe it, right? Then it's really nice to see. It's pretty close, isn't it?
Yeah.
And why isn't it, it's maybe not perfect, right? It's a little bit of an experiment, but that's pretty darn close. That makes sense? So this little investigation was supposed to get your brain thinking about comparing. It wasn't supposed to come out with exact answers. You're supposed to be able to compare lengths and perimeters and areas and learn how to use the words similar and proportional and corresponding. You have to know those words for this book. That was the whole point of it. So if it wasn't perfect, like, it's interesting, who was asking the most questions and, like, sort of answering a lot of questions today? Sammy was doing that, right? And who had wrong measurements? Sammy, right? So she learned last night by doing that with the wrong measurements. Like, some of you guys didn't get as far as measuring and probably it's not as useful. But by doing all that and maybe making some measuring errors, she was trying harder to figure it out. I think she kind of, like, gets it because she already sort of did the experiment. If some of you went home and didn't do the experiment, it's not as, it doesn't stick with you as much. So do the experiment. Okay? Okay, one thing about your homework that's really important before you all start getting up and walking away like you've been excused because you haven't, is you're going to see in your homework a tower problem. Okay, looking like this. Just relax. Okay, it just says if a man on the ground is about 6 feet tall, about how high is the tower? Now, do you need a ruler? No, right? I just did this like 10 times without a ruler, right? What would you do, Grant? Well, if you knew this was 6 feet, what would you do? Yeah, you would just stack it. And the only other thing in your homework that's review is percents, we talked about it last week, and area rectangles and parallelograms. Have a good day, guys. I'll post this